Hey guys, welcome back to the channel. Today I'll be explaining some hacks to make your process of solving problems regarding some applications of trigonometry easier. This chapter is part of the prescribed CBSE Class X Math curriculum, and it's Chapter 9 in your textbook. So there's a preconceived notion that this chapter is difficult, mainly because it involves trigonometry. But as I was going through it, I found out that if you apply these hacks, your problem-solving methods would become a lot easier. So let's begin with hack number 1. Use diagrams to your advantage. The first thing you want to do when you read the question is create a skeleton diagram of the primary message that the question is conveying. So this question above is directly from the 2022 CBSE Term 2 sample paper. So when you read the question, you see two vertical poles of different heights. So you immediately draw two straight lines perpendicular to a base. You see that they're standing 20 meters away from each other. So mark 20 meters. And then you see angle of elevation, one of them is 60 degrees and the other one is 30 degrees. So you immediately draw that. The benefits of drawing diagrams are that it breaks down the question and it makes it simpler for you to answer. And it also allows you to visually process the question, which are all beneficial towards quicker solving and more effective solving. Keep in mind that you shouldn't create any complex drawings. Limit yourself to only points and lines because during the exam, time is a limited resource. You can see here that I drew around 4 lines and 2 angles. That's all you need. At the end of the day, it's for your own benefit. You're not trying to impress anyone with your art skills. And also, although I didn't do any labeling here, during the exam, it's important to label your points. Because when you go on to solve and implement the trigonometric ratios and values, then it would be effective for you and more efficient for the examiner when he's correcting your paper to understand what your solving process is. So label your points, just A, B, C, D, or P, Q, R, or whatever suits you best. Hack number 2 is to know your trig values at the tips of your fingers. And you may be wondering why, because simply put, the problems cannot be solved without these values. So this table here enlists all the values of sine, cos, tan, cosecant, secant, and cotangent. And in the CBSE curriculum, you only need to know the values of 5 angles, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And I'll make it even easier for you because you don't even have to know 0 degrees or 90 degrees. Most of the questions are centered around 30, 45, and 60. And hack 2.5, this is somewhat in line with hack 2. If you memorize a sine value, then you can automatically derive the other trigonometric values. So if you know sine, then you know that the cos values are reverse of sine values, and I'll show you what that means. As you can see here, sine goes from 0 to 1 progressively from angle 0 degrees to 90 degrees. 0, 1 over 2, 1 over root 2, root 3 over 2, and 1. And cos is the exact reverse of that. It goes from 1 to 0, so sine is ascending order from 0 to 1, and cos is descending order from 1 to 0. So 0 and 1 are constant here, and so are 1 over 2, 1 over root 2, and root 3 over 2. And at 45 degrees, the value is same for both. So first, if you memorize the sine value, then for cos, you can just enter the reverse value of that. Instead of 0, 1 over 2, 1 over root 2, root 3 over 2, 1, the cos values are 1, root 3 over 2, 1 over root 2, 1 over 2, and 0. And tan is mathematically defined as sine over cos, or sine divided by cos. So to find out the values of tan, you just have to divide sine by cos. So for 0 degrees, 0 divided by 1 is 0. And for 30 degrees, 1 over 2 divided by root 3 over 2 is 1 over root 3. And if you implement this formula for all the values, then you get your answers. And lastly, cosecant, secant, and cotangent are all reciprocal values of sine, cos, and tan respectively. So cosecant is the reciprocal value of sine. So since sine 0 is 0, then cosecant 0 is also 0. And sine 30 is 1 over 2, so cosecant is 2, or 2 over 1. Secant is the reciprocal values of cos, and cotangent is the reciprocal value of tan. And hack 2.75 is that most of these questions that you'll get from this chapter are involving the tan value. And let me explain why. Because the question usually 9 times out of 10 demands the altitude or base length. And the one ratio that can find both of these values is tan, which is the altitude value by the base value, or altitude value divided by the base value. So most of the questions are tan. Hack 3. Differentiate between AOE and AOD. Now AOE and AOD are not Greek and Latin, it's just an abbreviation for angle of elevation and angle of depression, so don't get too worried about that. Angle of elevation and angle of depression, it's essential to differentiate between these because the questions could be worded in a way where you can get confused between which one's pointing up and which one's pointing down. So it would be ideal for you to have a comprehensive understanding of both of these values. So there's always a horizon line, and if the horizon line is ground level or at the bottom, and you're looking from a shorter object to a taller object, then we would have the angle of elevation. So in this diagram, the shorter object is the white arrow, and the taller object is the blue arrow. And since we're looking up from the short arrow to the top of the blue arrow, then the angle of elevation would be from that point, from those 2 points. So it'd be 30 degrees here. Similarly, continuing from the blue arrow, suppose somebody is looking from the blue arrow downwards to the shorter white arrow. In that case, the horizon is above the ground level, and so the angle of depression would also be on top. So a simple way of putting this is angle of elevation is always looking up. That's why it's elevating, which means going up. And angle of depression is looking down. Depress means downwards. It's also where the mental condition depression comes from, because people are always down. Their emotions are down. Their feelings are down. That's why it's called depression. But that's besides the point. Angle of elevation is looking up, and angle of depression is looking down. Hack number 4, always dissect the triangle. This is something that you should do before the exam, like way before. And you should have these facts at your fingertips. These are vital. So this is the basic dissection. We have an altitude, a base, and a hypotenuse. The hypotenuse is always the longest side, the base is what's facing the ground, and the altitude is the height, which is pointing upwards. That's simple. Now the advanced dissection, we have a right angle here. The right angle is always opposite to the hypotenuse. And then we have the angle of elevation, which is also, in this case, it could be the adjacent angle. And you have the angle of depression facing upwards. So this is an advanced dissection, and this is the basic dissection. They both have similar components, but obviously the advanced dissection has a few more added components. We have the right angle, which is essential to trigonometry because all the problems are revolving around right angle triangles. If it's not a right angle triangle, then it's not a trigonometric question, simply put. Hack number 5, know your trigonometric ratios. So trigonometric ratios and values are different. So we have sine, cos, tan, cosecant, secant, and tangent as usual. So the sine value is the ratio between the opposite side and the hypotenuse side. So the opposite side divided by the hypotenuse side is equal to the sine value. The cosine value is adjacent divided by hypotenuse. Tan value is opposite divided by adjacent. And cosecant is hypotenuse divided by opposite. So this is simple stuff. It was already discussed in the previous chapter, chapter 8, Introduction to Trigonometry. But without these ratios, then you're not able to solve the question. So you have to have the trigonometric values for those 5 angles and these trigonometric ratios at your fingertips. Secant is hypotenuse by adjacent and cotangent is adjacent by opposite. So there's a simple abbreviation to kind of minimize this and make it easier for you to remember. So we have SOHCAHTOA, SOHCAHTOA. So the first 3 letters is a 9-letter word. It's not a real word, it's made up, it's just an abbreviation. But SO stands for sine is equal to opposite by hypotenuse. And remember, opposite is just the altitude. It's another, you can say altitude, opposite, height, or any of these terms. So sine is equal to opposite by hypotenuse. And the next 3 letters, CA. Cos is equal to adjacent by hypotenuse. So the adjacent side is commonly known as the base as well. And in the last 3 letters, TOA. Tan is equal to opposite by adjacent, or height by base. So by knowing SOHCAHTOA, you don't have to memorize each value. And as I mentioned earlier, if you know the sine, cos, and tan values, then knowing the cosec, sec, and cot values are just a matter of reciprocation. That's why we look at SOHCAHTOA. Sine is equal to opposite by hypotenuse, cos is equal to adjacent by hypotenuse, and tan is equal to opposite by adjacent. This is a simple abbreviation to keep this in your mind. And the last hack is dissecting the question. So the first thing you have to do when you look at the question is you have to find an efficient method of going through the question, an efficient solving method. So first you start by highlighting the important information. So we see some measurements. We have a boy that's 1.7 meters tall. He's standing on a horizontal ground. So we have the shorter object's height here, which is the boy, and we know that he's standing on the horizontal ground. So since he's standing on the ground and the horizon is the base, we already know that this question would involve angle of elevation. And we can also see here that he's 50 meters away from a building. So there's a distance, or the base value would be 50 meters. And similarly, the angle of elevation from the top of the building is 60 degrees. So we even have the angle of elevation here. And we just have to find the height of the building. So always break down the question to given and find. So we're given the boy's height and the horizontal length between them and the angle of elevation. And we have to find the height of the building. So first things first, you have to draw your diagram. As you can see here, I made a simple skeletal diagram with just points and lines. We have a horizon ground. We have the boy. We have the angle of elevation. Now remember, it said the top of the building from his eye. So we have to consider from top of 1.7 meters. So the height of the building will also include the height of the boy plus the height of the altitude of the triangle. So after you drew your diagram, you have to apply our values. So we know that we have 60 degrees. And as I mentioned, most of the questions involve tan. So tan 60 is equal to altitude by adjacent. Now can you find out a mistake that I made here? That's right, I forgot to label the points. If I labeled the points, it would have been a lot easier for me to understand, for you to understand, and for the person that corrects my exam paper to understand. So rookie mistake is forgetting to label the points. So don't forget to do that. So we have altitude by adjacent, which would usually be AB over BC. AB over BC. So we know that the base value is 50 meters since the distance from the boy to the building is 50 meters. And we also know the value of tan 60, which is root 3. So root 3 is equal to altitude by 50 meters. And if we cross multiply, we get 50 root 3 is equal to the altitude. Now remember, the question is not limited to only finding the value of the altitude or the height of the triangle. We also have to find the height of the building as a whole, which includes the height of the boy. So the height of the building is equal to height of boy plus altitude. If we substitute our values, we get height of building is equal to 1.7 meters plus 50 root 3 meters. And the question said that we could use root 3 as 1.73. So 1.7 plus 50 times 1.73 is equal to a grand total of 88.3 meters. So the height of the building is 88.3 meters. So this is a comprehensive overview of how to find a step-by-step solution, making yourself time efficient and also using your resources effectively. So that concludes this short video on some hacks that could help your problem-solving method towards approaching some applications of trigonometry problems. As always, thank you so much for watching, and until the next video, this is Nishal Dube signing off. Peace.